Welcome to Revise and Resubmit, where we take cutting-edge research and try to break it down so you don't have to. I'm Pavlov, and with me as always,
Nikita.
All right, so today we're diving into some AI research that could totally change how we interact with machines.
Yeah, this is really cutting edge stuff.
Imagine like a computer that can understand ideas, not just words.
Yeah, that's the goal.
You can like summarize a complex paper even in languages it's never seen before.
That's the ambitious goal of the Large Concept Model, or LCM.
So we're exploring a research paper from Meta's AI team.
It was just published like a couple weeks ago on December 12th, 2024.
It's all about this new approach to language modeling.
Yeah, it's really different.
So get ready to like ditch the idea of computers processing language word by word.
Totally.
This deep dive is all about how this model operates on a higher level.
It works with concepts instead of individual words.
So what's fascinating to me is that current large language models, the LLMs,
Yeah.
they're great at mimicking language. Like they can write poems, generate code, even hold conversations.
They're really good at that stuff.
But when it comes to like actually understanding, they fall short.
They're more like parrots mimicking what they've heard, but not really getting the meaning.
That's a great analogy.
Hey, thanks.
So you're saying they're good at playing the language game,
Yeah,
but not so good at understanding the rules.
exactly.
So they're really good at like predicting the next word in a sequence,
That's their strength.
but they struggle with abstract concepts and like that hierarchical thinking.
Yeah, they don't grasp the big picture the way humans do.
Right, because we don't just like string words together randomly when we think and communicate.
We don't.
We create mental outlines and make connections between different parts of a text.
Right, and we search for information based on ideas, not just keywords.
Precisely.
If you think about a researcher giving a talk,
Okay,
they don't plan out every single word beforehand.
they're thinking about the flow.
Yeah, they focus on the flow of ideas and the key concepts they want to convey.
And that's where the LCM comes in.
That's where it gets really interesting.
Okay, so how does this large concept model actually work?
Well, it's different.
Yeah, it sounds like it's approaching language in a totally different way.
It processes information in an embedding space of concepts,
Okay.
which are basically sentence-level representations of meaning.
Okay.
So, like, imagine a mind map
Okay.
where each node represents the meaning of a sentence.
I'm with you.
And the LCM is figuring out how all these nodes connect and relate to each other.
Okay, I'm starting to get the picture.
Good.
But what makes this approach so special?
Well, there are a lot of advantages.
Like, what are the advantages of thinking in concepts instead of words?
Well, for one, you know how most AI models are stuck with English?
They are very English-centric.
The LCM is different. It uses a system called Sonar,
Okay.
which can handle text and speech in over 200 languages, even sign language.
Wow, that's really impressive.
It is.
So it's like this thing can pick up a new language just by understanding the underlying idea.
Exactly. It's language agnostic,
Wow.
which opens up a ton of possibilities.
Yeah, that's huge.
But that's not all.
Okay, there's more.
It also has this explicit hierarchical structure,
Okay.
which makes its output more coherent and easier for us humans to understand and edit.
Makes sense.
And it can handle these really long contexts and outputs efficiently.
That's good.
And get this, it has incredible zero-shot generalization capabilities.
Okay, you're going to have to explain that one.
It means it can perform well on tasks it's never been specifically trained on.
Wow. Okay, color me impressed.
It's pretty cool.
But how do you even begin to train a model to think in concepts?
That's the challenge, isn't
That
it?
sounds like a huge task.
It is. The researchers explored several different techniques,
Okay.
each with its own strengths and weaknesses.
So, like, what were some of the approaches they tried?
Well, one approach is called base LCM,
Okay.
which uses a simple regression technique to predict the next concept's embedding.
So it's kind of like a connect the dots game, but with meanings instead of dots.
That's a good way to think about it.
I like that analogy.
They also experimented with something called diffusion models.
Diffusion models.
Yeah.
Okay, I know that term from image generation.
Exactly. It was actually inspired by that field.
How does image generation tie into language modeling?
Well, imagine you take a perfectly clear photo and you slowly add more and more static
Okay, I'm with you.
until the original image is completely obscured.
It's like a blurry photo.
Yeah, that's essentially what diffusion models do during training.
Okay.
They add noise to the data, and the LCM is trained to reverse this process.
So it's learning to extract the meaning from the noise.
Exactly.
So it's like learning to see the signal through all the noise.
Precisely. It's a really clever way to force the model to consider multiple possible interpretations,
Okay.
and to become more robust in the process.
So they're teaching the model to deal with ambiguity.
Yeah, just like we have to do in real life.
I like it.
And finally, they experimented with something called quantized LCMs.
Quantized.
Yeah.
Okay.
Which break down the concept space into these discrete units.
It's like taking something continuous and breaking into chunks.
That's a great analogy.
I'm full of them today.
So instead of working with these complex multi-dimensional embeddings,
Right.
they're creating a sort of digital code for concepts.
I see. So they're simplifying it in a way.
Yeah. And this has some advantages in terms of computational efficiency and control over the output.
That makes sense. So they developed all these different training techniques.
Yeah, that did a lot of work.
But they also made some pretty interesting discoveries along the way.
Oh, yeah, for sure.
Okay, I love a good discovery. What did they find?
Well, one thing they found was that the way you split text into sentences
Okay.
actually has a huge impact on how well the LCM performs.
Wait, are you serious?
Yeah, it's true.
So, like, where you put a period can actually affect the model's understanding?
It really can. Sentence segmentation matters a lot when you're working with these high-level concepts.
Wow, I would have never thought of that.
They even found a specific tool that worked best for this.
So it's not just about the algorithms. It's also about the details of how you prepare the data.
Exactly. Those little things can make a big difference.
What was the other intriguing finding?
They stumbled upon this idea of fragile embeddings.
Fragile embeddings.
Yeah.
What does that even mean?
Well, think of it like a game of telephone.
okay.
Some concepts get passed along perfectly while others get distorted along the way.
I see.
So the LCM is figuring out which embeddings are more likely to get lost in the game.
So some embeddings are more reliable than others.
Exactly.
That's interesting.
They found that certain types of embeddings are more susceptible to noise and distortion.
Like what kind of embeddings?
Things like hyperlinks code or really complex technical terms.
Stuff that's hard to understand.
Yeah, stuff that Sonar struggles with.
So the model is basically raising a red flag.
Yeah, you could say that.
Like, hold on. I'm not so sure about this part.
That's a good way to think about it.
That's pretty cool. But they didn't just stop at developing the architecture, right?
Oh, it did.
They wanted to see what this LCM could actually do.
They wanted to put it to the test.
Exactly. So they took this model and they gave it some real world data.
Yeah, but before we get into that,
Yeah.
let's shift gears a bit
Okay, I'm ready for a change of pace.
and talk about how they actually put the LCM through its paces.
Like the AI Olympics.
Exactly. Are you ready for the mental gymnastics?
Bring it on.
So they scaled up their two-tower model
Okay.
to a whopping 7 billion parameters.
7 billion.
It's huge.
That's massive.
They called it two-tower 7B,
Okay.
and they trained it on a massive data set.
I can only imagine.
And then they tested it on some seriously challenging tasks.
Okay, like what? Like
Summarization.
summarization.
Yeah, taking longer documents and creating concise summaries.
Okay, but like what kind of real world data did they use?
They use data sets like CNN, Daily Mail, and XSum,
Okay, I've heard of those.
and also this long document-focused data set called LCFO.
So like real articles and stuff.
Exactly, real-world data.
Okay, so they put this thing to the test.
It did.
How did it do?
It did really well.
Like, was it as good as those super smart LLMs we keep hearing about?
It actually outperformed them on some metrics.
Really?
It was especially good at generating abstractive summaries.
So it wasn't just copying and pasting.
No, it was actually understanding the meaning and like distilling it into a concise summary.
That's impressive.
And it was able to handle those super long documents.
The ones that trip up other models.
Exactly.
So it's showing real potential in an area where many LLMs struggle.
It really is.
That's exciting?
And remember how we talked about the LCM's ability to understand multiple languages?
Yeah, that was mind-blowing.
You didn't just theorize about it.
No, they put it to the test.
They did.
Okay, hold on to your hats because this is where things get really interesting.
They evaluated it on the XLSum dataset,
Excel sum.
which has news summaries in 45 different languages.
45 languages.
Yeah, it's a lot.
Yeah.
The LCM, trained only on English data,
Wait, what?
showed remarkable zero-shot performance on many of those languages.
So it had never seen those languages before.
Nope, never seen them.
And it could still understand them.
It could. It even beat a multilingual LLM called Llama 3.18BIT.
Seriously?
Yeah, on several languages.
Wow, that's incredible.
It's not just understanding multiple languages in theory
It's actually performing well in them.
without any specific training.
Now that's what I call walking the walk.
It really is,
It highlights the power of this language agnostic approach.
for sure. But the team isn't stopping there.
Of course not.
They're already thinking about how to make the LCM even better.
Okay, like what?
especially at generating longer coherent text.
So, like full articles or stories?
Exactly.
Okay, what are they working on?
One idea is adding a planning module.
A planning module.
Yeah, or LPM for short.
Okay.
Which creates high-level outlines or summary.
Of what the LCM should generate next.
Right.
So it's like giving the LCM a roadmap
That's a good way to put it.
before it starts writing.
Exactly.
Like a writer creating an outline.
Precisely.
This planning module could lead to even better results.
In terms of coherence and structure,
So a little bit of planning goes a long way.
it seems so.
But what's really blowing my mind here is this whole concept of thinking in concepts.
It's a big shift.
It makes you wonder if this is how we actually think too,
Yeah, maybe our brains are working with these abstract representations of meaning.
instead of just words.
Well, it's a fascinating question.
It really is. And some theories suggest that we do think in a more conceptual way.
It's definitely possible.
So maybe the LCM is actually getting closer to how our brains work.
Then those traditional LLMs.
That's a really cool thought
It opens up all sorts of possibilities.
for understanding how we think.
And for developing even more sophisticated AI.
Okay, so we've talked about how the LCM works and what it can do.
We've covered a lot.
But what does this all mean for us humans?
Well, the implications are huge.
Like what kind of implications?
Imagine the possibilities for cross-cultural communication,
Yeah, if machines can process information on a conceptual level,
independent of language.
it could break down so many barriers,
Exactly. We could have much more accurate translation,
making it easier for people to connect and collaborate.
regardless of your language.
And what about education?
Education would be transformed.
Imagine students can learn from the best teachers anywhere in the world.
And access information in any language.
It's mind-blowing.
It really is.
And the LCM could change how we search for information.
Instead of keywords, we could search based on concepts.
So no more irrelevant results,
You could find exactly what you're looking for.
even if it's expressed differently.
Exactly.
And this brings us to another fascinating aspect.
What's that?
The implications for creativity.
Yes.
If machines can understand concepts, can they also generate their own ideas?
That's the big question, isn't it?
It's a question that's both exciting and a little bit unnerving.
It raises questions about the nature of creativity.
Is it something uniquely human?
Or can machines eventually replicate it?
Maybe even surpass us?
It's possible.
I mean, if a machine can understand concepts, can it also come up with its own concepts?
That's the million-dollar question,
It's something we'll be debating for years to come.
for sure. But one thing's clear. This technology has the potential to push the boundaries.
Of what we think is possible.
Absolutely.
Okay, so we've got all this amazing potential,
We do.
but what about the challenges?
There are always challenges.
What are the hurdles that researchers still need to overcome?
Well, one of the biggest is computational cost.
Of course, these models are huge,
Training them requires enormous amounts of data and processing power.
and not everyone has access to those resources.
Exactly. And even with all that power, training can take weeks.
So making these models more efficient is key.
For wider adoption and impact.
Absolutely. What other challenges are there?
Well, another challenge is evaluation.
Evaluation.
Yeah, how do you measure understanding in a machine?
That's a tough one.
It's not just about getting the right answer.
It's about understanding the why,
Exactly. Traditional metrics like accuracy aren't always enough.
especially with these conceptual tasks,
So we need better evaluation methods.
to track progress and make sure these models are really learning.
And not just mimicking.
You know, this whole thing reminds me of something I read about the history of AI.
Oh, yeah. What's that?
Well, for decades, the focus was on symbolic AI.
Where researchers try to program machines with explicit rules.
But that approach hit a wall.
The real world is too complex for rules.
It's like trying to teach a computer to understand humor.
There are just too many nuances.
That's where deep learning comes in.
where we let the machines learn from data.
And in the case of the LCM, it's learning to extract meaning and understand concepts
Directly from the data.
without relying on predefined rules.
It's a much more flexible and powerful approach.
And it's already leading to some amazing breakthroughs.
It really is.
So it's like we're finally starting to crack the code.
Of how to build machines that can truly understand.
Okay, we've covered a lot of ground here.
We have.
Before we jump into the technical details of how they trained this thing,
Okay,
let's do a quick recap.
sounds good.
First, the LCM is a radical departure from traditional LLMs.
It's all about concepts,
It uses the sonar embedding system
which lets it work with over 200 languages.
and even different modalities like speech,
It's very versatile,
And it's showing promise on challenging tasks,
like summarization,
even outperforming specialized LLMs.
in some cases.
It has this amazing zero-shot generalization capability.
Meaning it can perform well in languages it's never seen.
And we can't forget about those fragile embedding.
Those tricky representations
Identifying and understanding those is crucial.
for improving training
So how about we shift gears and dive into the technical details?
of how they trained this model.
Are you ready to get into the nuts and bolts?
Let's do it.
Okay, so let's get under the hood and see how they trained this large concept model.
All right, so those techniques we talked about, like base LCM and diffusion models,
Yeah.
they play a crucial role in teaching the LCM to think in concepts.
Okay, so refresh my memory. What was base LCM all about again?
Right. So base LCM, it uses a simple regression approach.
Okay.
It's basically trying to predict the exact coordinates of the next concepts embedding in that sonar space.
So like pinpointing a location on a map.
Exactly. But instead of latitude and longitude, you're dealing with the abstract coordinates of meaning.
So it's like a high-stakes game of where in the world is Carmen Sandiego, but with concepts.
That's a good one.
Thanks, I try.
But as straightforward as this method is, it has limitations.
Like what?
It assumes there's only one correct next concept.
Right, and that's not always true.
Exactly. Human thought isn't always linear.
Yeah, there might be multiple valid continuations of an idea.
Exactly. Like choosing a path at a fork in the road.
There could be multiple routes to your destination.
Right. So that's where those diffusion models come in.
Okay, back to the blurry photos.
Right. Remember we talked about adding noise to the data?
Yeah.
The LCM is trained to reverse this process and extract the original concept from all that noise.
So instead of aiming for one bullseye, it's navigating a whole field of possibilities.
Precisely. And this approach forces the model to deal with ambiguity and consider multiple interpretations.
It's like learning to think outside the box.
Exactly.
Now, you mentioned two types of diffusion LCMs, the one tower and the two tower.
Right.
What's the difference?
So the one tower model uses a single transformer network for everything,
For encoding and predicting.
for both, while the two tower model uses separate networks.
It's like a team of specialists.
You got it.
Did they find that this division of labor improved performance?
Yes, definitely.
Yeah.
The two tower model was much better at handling longer contexts.
And generating more coherent output.
Exactly.
Now, what about those quantized LCMs? The ones that created a digital code for concepts?
Right. So instead of working with those complex embeddings,
Yeah, they're kind of messy.
they created a dictionary of concept units
Okay.
and trained the model to predict sequences of these units.
So it's like translating the language of concepts into a digital code.
That's a great way to put it.
It's like pixels in an image. This approach simplified things and made it more computationally efficient.
It did. And it also allowed for greater control over the output.
Interesting. So they had all these different training methods,
Yep. They really explored the options.
but how did it actually perform?
They evaluated it on various tasks.
Okay, like what?
Summarization, summary expansion, zero-shot language generalization.
So like creating spark notes, turning a movie trailer back into a full film, and understanding new languages?
Exactly. A real mental workout.
They really put it through the paces.
They did. They used traditional metrics like accuracy scores,
Okay.
but also more nuanced measures like coherence and fluency.
So they were looking at both the correctness and the quality of the output.
Precisely. And how did it do?
It did remarkably well, often surpassing those state-of-the-art LLMs,
Really?
especially when it came to handling long documents and generating coherent output.
It sounds like it's pushing the boundaries of what we thought was possible.
It is. But as with any new technology, there are still challenges.
Like what computational efficiency is a big one.
Right. Training these massive models requires a lot of resources
It does. And finding ways to make it more efficient is crucial.
for wider adoption.
Exactly.
What other areas are there for future exploration?
Well, they focused on sentence-level representations in this paper.
Okay.
But you could explore other units of meaning like paragraphs or even whole documents.
Like adjusting the lens of a microscope.
Exactly.
That's a great analogy.
Thanks.
And I imagine integrating other modalities like images and sounds would be huge.
Imagine an AI that can understand a recipe by watching a cooking video.
That would be amazing.
It would require multimodal understanding.
And it would unlock so many possibilities.
It would. It seems like we're just getting started with the large concept model.
We're at a pivotal moment in AI research.
The shift to concept level understanding is going to be huge.
It's exciting and a little bit daunting.
It is. But one thing's for sure, this research is groundbreaking.
It makes you think about the future of AI.
And how we interact with machines.
This deep dive has been incredible.
I'm glad you enjoyed it.
It's really made me think about the possibilities.
That's what we aim for.
So what's next for the LCM?
Well, the research team has made their code and the Sonar embeddings publicly available.
So anyone can experiment with it.
Anyone? Maybe you'll make the next big discovery.
That's the beauty of it all.
The power of open research.
We'll be sure to include links to those resources in the show notes.
So check those out.
And be sure to check back for more deep dives into the world of AI.
We'll have more cutting-edge research soon.
Until next time, keep exploring, keep asking questions, and never stop learning. And don't forget to subscribe to Revise and Resubmit on Spotify and Apple Podcasts for more captivating deep dives like this one. And if you're enjoying the show and want to support us in creating more insightful content, consider becoming a patron on Patreon. Every contribution helps us continue this journey of exploration and discovery. Until next time, keep those minds curious, keep questioning, and keep revising and resubmitting.